What if every biology textbook you've ever read is just, well, fundamentally wrong? I really want you to think about that for a second.
Right, because it's a huge shift from what we're all taught.
Exactly. I mean, you've probably been taught that life on Earth is the result of this long, slow, kind of staggering series of lucky chemical accidents.
A random mutation here, a survival advantage there.
Yeah, and over billions of years, primordial sludge eventually turns into a human being. But today, we are looking at a document that claims to mathematically dismantle that entire narrative.
And it does so with some incredibly dense math.
It really does. So today we're doing a deep dive into a paradigm-shifting 2026 paper by George James Dukas. It's titled Adaptive Biogenesis, the Physics of Life.
Which is part of a broader framework, actually. It's called the Transdimensional Unified Field Theory, or TDUFT version 5.
Right, and the core argument here, life is not a random accident of chemistry. According to this author, biological life is a precise, mathematically engineered projection.
It's a truly radical departure from the scientific consensus. We're looking at a proposal to move from a biological universe governed by chance, natural selection, to one governed by absolute, rigid mathematical declaration.
And just to be clear about the materials we're examining today, this paper isn't just offering a mild critique of Darwinian evolution.
No, not at all. It is proposing a total foundational replacement. The text argues that life is it calls it a designed operator system.
A design operator system. Okay.
Yeah. It claims that the architecture of biology is dictated by universal mathematical constants, specifically the golden ratio, which mathematicians denote as phi, and e constant pi.
And the author attempts to back this up, right? With rigorous geometric proofs regarding the structure of DNA, detailed statistical models, and this core philosophical assertion that random processes simply cannot proceed non-random order.
Exactly. But before we get totally lost in the math, we should probably set some ground rules.
Definitely. So our mission today is to take this incredibly dense, equation-heavy document and translate it. We want to turn its mathematical proofs into concepts we can all grasp.
Because there is a lot of math here.
So much math.
Yeah.
But don't worry if you don't have a PhD in quantum physics or advanced calculus. We are going to break down the geometry, the statistics, and the biology together, step by step.
Right. We are acting as impartial guides through this framework. We're just examining how Dukas arrives at these conclusions. We aren't endorsing it or taking sides, just unpacking the source material.
Exactly. And by the end of this deep dive, you are going to understand the mechanics of an entirely different lens through which to view biological life. You'll see the structure of your own body, and maybe even the nature of consciousness itself, in a totally new way.
The most logical place to begin is at the foundation of the author's argument, which is a direct mathematical attack on the premise of random origins.
Standard abiogenesis.
Yes, exactly. The bedrock of modern evolutionary biology relies on abiogenesis. That's the idea that non-living matter, under the right conditions and given enough time, can spontaneously generate living organisms through random chemical interactions.
Just, bumping into each other until something starts breathing.
Right. But the author of this paper argues that this is not merely unproven. Dukas says it is mathematically impossible within the physical constraints of our universe. He mathematically excludes spontaneous life.
Let's slow down and look at the actual mechanics of that impossibility, because the text gives us some very specific, highly intimidating numbers.
It really does. The author calculates the probability of a minimal functioning cell forming by random chance.
We're talking about a basic structural cell here, right? Requiring roughly 500 specific proteins to operate.
Yes. And the probability Dukas calculates for this assembling randomly is 10 to the negative 2,500th power.
Okay, wait. Let's just pause on that.
It's a difficult number to grasp.
To really conceptualize what a number like that means, you have to imagine a decimal point followed by 2,499 zeros and then a 1.
Right. In statistical mathematics, a probability of that magnitude is indistinguishable from absolute zero. It just doesn't happen.
But what makes this argument compelling within the framework of the paper is the comparison the author draws to the physical universe itself.
Exactly. The entire observable universe contains roughly 10 to the 80th power atoms.
Okay, so let's put those two numbers in a wrestling ring. 10 to the 80th power atoms available to do the work versus odds of 1 in 10 to the 2,500th power.
It's no contest. If you were to take every single atom in the known universe and have each one participate in a unique chemical reaction millions of times per second.
Which is already impossible.
Right, but let's say you did. And you ran that process continuously for the entire 13.8 billion year history of the universe. You would not even come infinitesimally close to scratching the surface of 10 to the 2500th power.
Wow. So the author is using these constraints to argue that random abiogenesis is a mathematical absurdity.
Yes. The time and material available in the universe are simply insufficient to randomly generate the specified complexity of a single cell.
But hold on, let me play devil's advocate here, because this is where standard biology would push back. We often hear about the infinite monkey theorem.
The typewriters.
Right, the idea that if you have 1,000,000 monkeys typing on 1,000,000 typewriters for an infinite amount of time, eventually one of them will accidentally type the complete works of Shakespeare.
It's a classic thought experiment.
Yeah. So if the universe is vast enough and time is long enough, isn't time the magic ingredient that makes the improbable inevitable?
That is exactly the standard defense. But Dukas rejects the infinite monkey theorem in this context by pointing to a concept the paper calls the chirality impossibility.
Chirality impossibility. Okay, break that down for us.
This moves the argument from pure probability into the physics of energy. In chemistry, amino acids, which are the building blocks of those proteins we just mentioned, have a property called chirality. It basically means handedness.
Handedness, like left-handed and right-handed.
Exactly. Because of their 3D molecular structure, they can form in two mirror image configurations. There's left-handed, which is L-chirality, and right-handed D-chirality.
Okay, so it's like a pair of gloves. They have the exact same fingers, the same material, but you can't put a left glove on a right hand.
That is a perfect visualization. Now, if you conduct a random chemical experiment in a laboratory to create amino acids, the laws of chemistry dictate that you will produce what's called a racemic mixture.
Which is what?
It's an exactly equal 50-50 split of left-handed and right-handed molecules. It's a purely random distribution.
Okay, that makes sense for a random chemical soup.
Right. However, biological life on Earth is completely asymmetric. Every single protein and every single living organism exclusively uses left-handed L-chirality amino acids.
Wait, all of them? Every single one?
Every single one. If even one right-handed amino acid is inserted into a protein chain, the protein folds incorrectly and becomes useless, or even toxic.
Oh, wow. So the monkey on the typewriter isn't just trying to type Shakespeare, it's trying to type Shakespeare using a keyboard, where half the keys instantly destroy the entire manuscript the moment they are pressed.
Yes, that's exactly it. And the paper states that this exclusive left-handed bias cannot be a random selection that just happened to win out in the primordial soup.
Because the odds are just too crazy.
Right. Dukas frames it as an energetic declaration. The mathematical framework of TDUFT calculates a specific energy bias, 11.1 electron volts, that forces this left-handed asymmetry at what the author calls the operator level.
Let's clarify that term for a second. An electron volt is a unit of energy, usually used in particle physics, to measure the energy gained by an electron moving across a voltage difference. So what does an 11.1 electron volt bias actually mean in this biological context?
In the author's framework, it means the universe is not indifferent to the geometry of life. There is a fundamental built-in energetic pressure, a force of 11.1 electron volts that actively suppresses the right-handed molecules and mandates the left-handed ones for biological construction.
So it was declared by the underlying physics, not randomly selected by environmental trial and error.
Precisely. The universe basically forced it to be left-handed.
The paper also leans heavily on what it calls the information impossibility.
Yes, that's another core pillar.
The argument here is that random mutations overwhelmingly destroy biological function. They don't create specified complexity. I was actually trying to think of an analogy for this.
Go for it.
Let's say you want to build a state-of-the-art skyscraper. You have all the raw materials, right? Steel, glass, concrete, copper wiring. The Darwinian model, according to the critique in this paper, is essentially saying that if you throw millions of bricks and beams into a tornado, and you let that tornado spin for 1 billion years, the random collisions of those materials will eventually assemble a fully wired, plumbed, perfectly engineered skyscraper.
Which is obviously absurd when you frame it like that.
Right. Dukas is arguing that order must be structurally prior to chaos. You cannot get the skyscraper from the tornado, no matter how long the wind blows.
The author is stating that the physical universe inherits its order from a pre-existing mathematical system. Every physical structure we see, especially biological life, is a downstream projection of a higher dimensional mathematical declaration.
So the math comes first.
Always.
Yeah.
What we perceive as randomness, mutations, noise, entropy, is just the degradation of that original order. So the text is asking the reader to entirely invert their perspective.
It shifts the perception of life from being a lucky accident of primordial sludge to being a mathematical certainty born of a rigid, pre-existing template.
It is a staggering inversion.
But if we follow Ducas's logic here,
Mhm.
if life didn't start as simple sludge and evolve upward through random mutations over billions of years, then what exactly is happening when we look at the fossil record?
That is the big question.
Right, because clearly life on Earth has changed dramatically over time. This brings us to a highly counterintuitive section of the paper, the myth of progression and the reality of what the author calls de-evolution.
This part is fascinating. The paper argues that the arrow of biological change actually points downward.
Downward.
Yes, it points towards simplification under entropic pressure, not upward toward greater complexity. According to the TDUFT framework, biological life was declared at its absolute maximum operator complexity from the very beginning.
Wait, maximum complexity at the beginning. But the standard view of the fossil record seems to show simple, single-celled organisms appearing first and complex mammals appearing much later. Doesn't that directly contradict this framework?
Well, Dukas addresses this by pointing to the Cambrian explosion.
Oh, right. The sudden burst of life.
Exactly. In the geological record, roughly 540 million years ago, there was a relatively brief period where virtually all major animal phylae, the fundamental body plans of life, suddenly appear in the fossil record without clear, simple precursors.
It's always been a puzzle for evolutionary biologists.
Standard evolutionary biology views this as a period of rapid, unexplainable evolutionary radiation. Dukas, however, interprets the Cambrian explosion as the initial materialization, the exact moment of maximum biological declaration.
So all the complexity was dumped into the system at once.
The argument is that from that point of maximum complexity onward, life has actually been degrading, fragmenting, or collapsing to survive.
The narrative the text uses about dinosaurs illustrates this adaptive collapse concept perfectly.
The dinosaurs are a great example here.
Dinosaurs dominated the Earth for over 165 million years. Under this paper's theory, a Tyrannosaurus rex or a Brachiosaurus were extraordinarily complex operator expressions.
They required massive amounts of energy, highly stable environments, and immense biological resources to maintain their geometric strictures.
And they didn't evolve upward into something better.
No, they didn't. The paper looks at the Chicxulub asteroid impact, the catastrophic event that wiped out the dinosaurs.
Right, a massive environmental shock.
That impact drastically and violently changed the entropic environment of the planet. It blocked out the sun, killed off the plant life, and plummeted the global temperature. The energy and resources required to maintain massive, complex dinosaur biological systems simply were not available anymore in that new high-entropy environment.
And so, according to standard theory, some small theropod dinosaurs adapted and eventually evolved into birds.
Yes.
But Dukas flips the wording entirely. The text says birds aren't an evolutionary step forward from dinosaurs. They're a de-evolved remnant.
Exactly. The author defines them as smaller, lower inertia forms of the original dinosaur operator configuration. They shed massive amounts of biological complexity in order to survive in a much harsher, energy-poor environment. It is an adaptive collapse.
I think I have a solid modern analogy for this.
Let's hear it.
Imagine you have a top-of-the-line, immensely powerful, energy-guzzling supercomputer. It can run incredibly complex simulations, render 3D graphics in real time, just an absolute marvel of engineering.
Okay, I'm with you.
But then the main power grid to your city fails. You are suddenly relying on a tiny, low-voltage solar backup battery. You cannot run the supercomputer on that battery.
It would just shut down.
Exactly. To survive the power outage and continue doing basic calculations, you don't evolve your supercomputer into an even bigger, more complex machine. You de-evolve
You
it.
strip it down.
Right. You strip out the graphics cards, you shut down the cooling systems, and you reduce it to the processing power of a basic pocket calculator just to keep the core mathematical functions running. In Dukas's framework, that pocket calculator is the bird. The supercomputer is the T-Rex.
That analogy captures the mechanism perfectly. It is entirely about maintaining a viable operator state under increased environmental pressure. The organism must simplify to reduce its energy requirements.
Because complexity requires energy.
Exactly. The paper highlights a staggering, widely accepted scientific statistic to back this up. Over 99% of all species that have ever existed on Earth are now extinct.
99%.
Dukas asks why. The paper's answer is that life is catastrophically fragile outside its designated operating range. Biology is built to a specific, highly complex mathematical standard. When the external environment strays too far from what that standard can energetically tolerate, the form either goes extinct entirely or it collapses into a simpler, less demanding version of itself.
If we extrapolate that logic, if 99% of life has collapsed or gone extinct under entropic pressure, what does that imply for human biological complexity?
It's a dark thought.
It really is. Under this theory, we aren't the pinnacle of an upward climb. Are we also just a simplified remnant of a more complex past operator? It is a deeply sobering way to view our own species.
It forces a complete reevaluation of human biology, yes. But the paper doesn't just theorize about collapse. It attempts to prove exactly what that original maximally complex mathematical standard actually is.
If life is a supercomputer that degrades over time, where did the initial blueprint for the supercomputer come from?
The text points directly to the geometry of DNA.
Which brings us to what is arguably the mathematical heart of this entire deep dive, the golden ratio shell construction of DNA.
This is where Dukas transitions from philosophical critique to formal mathematical proof. The author introduces the TDUFT shell equation. In relatively simple terms, the paper proposes that B-form DNA, which is the standard, most common form of DNA found in our cells, is a geometric construct perfectly predicted by the golden ratio.
Okay, let's make sure we are all on the same page about the golden ratio. Mathematicians call it phi. It's an irrational number, roughly 1.618.
Right.
It is a mathematical constant that shows up everywhere in the natural world. It dictates the spiral of galaxies, the arrangement of leaves on a stem, the pattern of seeds in a sunflower, and the curve of a nautilus shell. It's considered the geometry of optimal growth and proportion.
Yes, and Dukas argues that it is the fundamental declarative geometry of biology. The paper applies a specific equation to DNA. It's R sub n equals a sub 0 times phi to the power of 2 times n minus 1.
I realize reading raw equations out loud can sound like abstract alphabet soup, so let's translate this into the physical space of a DNA molecule.
Good idea. The equation requires a baseline starting measurement. The author uses the basic building block of DNA, which is the base pairwise. The distance between one rung on the DNA ladder and the next rung up is 3.4 angstroms.
Just to clarify the scale here for you listening, an angstrom is a unit of length used to measure atoms and molecules. It is 1/10,000,000th of a meter. It is unimaginably small.
Unimaginably small.
So starting with that tiny 3.4 angstroms as our foundational building block, what does the equation do?
The author plugs that 3.4 baseline into the phi-based shell equation, and the math mathematically generates the rest of the macrostructure of the DNA helix. The resulting measurements are astonishingly precise.
How precise are we talking?
The length of one complete 360-degree turn of the DNA helix is exactly 34 angstroms. The total width or diameter of the helix is 21 angstroms.
Hold on, I see what's happening here. The numbers 21 and 34.
You see the pattern?
If we look at the Fibonacci sequence, which is the famous mathematical series where you add the previous two numbers together to get the next one. So it goes 1, 1, 2, 3, 5, 8, 13, 21, 34. The numbers 21 and 34 sit right next to each other in the sequence. They are Fibonacci 8 and Fibonacci 9.
Precisely. And a core property of the Fibonacci sequence is that as you go higher in the numbers, the ratio between adjacent numbers gets closer and closer to the exact infinite decimal of the golden ratio, phi.
So if you do the math on those DNA measurements,
if you take the DNA helix turn measurement of 34 and divide it by the DNA diameter of 21, you get a master structural ratio of 1.61904.
and the exact pure mathematical constant of the golden ratio is 1.61803.
That leaves an error margin of a microscopic 0.06%.
Okay, let's pause and really look at what Dukas is claiming here.
Right.
We're talking about the literal blueprint of human biology, the microscopic scaffolding inside every single cell in your body, and it matches a universal mathematical constant to roughly 1,000th of a decimal place.
It's mathematically stunning.
But I have to push back. Human beings are incredibly good at pattern recognition. We see faces in clouds, we see shapes in toast. It's called pareidolia.
We do love finding patterns.
If you look at enough measurements of anything, eventually you'll find a ratio that looks like phi. How does the author prove this isn't just cherry-picking numbers to fit a theory?
That is a crucial scientific objection, and the author attempts to preempt it by providing a formal chi-square convergence proof. The text states the chi-square value is 0.14 with a p-value greater than 0.99.
Okay, let's translate that statistical jargon into plain English. How does a chi-square test actually work?
A chi-square test is a statistical method used to compare observed data, in this case, the actual physical measurements of DNA in a lab against expected data, which are the hypothetical measurements generated purely by Ducas's mathematical phi equation.
So it tests reality against the theory.
Right. It measures how much the real world deviates from the theoretical model. A low chi-square value means the real-world data matches the mathematical model very closely. The p-value tells you the probability that this match could have happened just by random chance.
So what does a p-value of greater than 0.99 mean in this context?
Well, in standard biology, a p-value of 0.05 is usually considered statistically significant. A p-value greater than 0.99 is almost unheard of. It effectively means there is a 99% certainty that the geometry of DNA is completely dependent on the golden ratio equation provided.
Wait, really?
Yes. According to the paper's math, the probability of random, undirected chemical assembly producing this highly specific phi-based geometry by sheer luck is indistinguishable from zero. It is a formal statistical assertion of engineered construction.
The text also points out a fascinating detail about the cross-section geometry of the molecule. If you were to take a DNA helix, cut it in half, and look at it end-on straight down the barrel of the spiral, the atomic bonds form a decagon.
A 10-sided shape.
Right. Which structurally consists of two rotated pentagons. And in classical geometry, the pentagon is the purest two-dimensional manifestation of the golden ratio. The diagonals of a pentagon literally cross each other at golden ratio proportions.
The implication Dukas is making is that biology isn't just randomly shaped. It is a rigid physical manifestation of the golden ratio. Phi is the operator that handles the spacing, the steps, the discrete physical shells of the biological structure.
But it's not just steps, right?
No, however, DNA is not just a straight ladder, it is a double helix. It twists into a continuous spiral. And in physics and mathematics, whenever you are dealing with circles, spirals, or continuous rotation, you must introduce the other fundamental universal constant, which is pi.
Right. Phi governs the straight lines and the spacing, but pi governs the curve. So if DNA incorporates both, how do these two universal constants interact? How do they share the same physical space?
The paper calls this interaction the eternum nexus identity. It acts as a dimensional bridge.
A dimensional bridge.
Yeah.
Let's walk through how Dukas explains this concept.
This is where the framework attempts to unify physics and biology. The paper posits that DNA is the specific structure designed to encode the complete transition from the pi domain to the phi domain.
The pi domain being what, exactly?
In TDUFT theory, pi represents continuous rotation, wave mechanics, and conceptually, the spirit or the energetic pre-creation wave. Phi represents discrete spatial stepping, rigid atomic spacing, and the material biological world.
So how exactly does the DNA molecule physically bridge a wave concept like pi with a structural concept like phi?
The author points back to the measurements we just discussed, but looks at how they couple together. The 34 angstrom longitudinal turn of the helix encodes the pi circumference. It dictates the rotational circle of the molecule.
Okay, so the term is pi.
Meanwhile, the 21 angstrom lateral diameter encodes the phi spacing, the physical boundary of the structure. But the real magic, according to the math, happens in the angle of the twist.
Yes, the text gets very specific here. A standard B-form DNA helix has exactly 10 base pairs, 10 rungs on the ladder for every single full twist of the spiral. If you take a full 360-degree circle and divide it by those 10 steps, you get exactly a 36-degree angle of rotation between each base pair.
And that 36-degree angle is the crux of the eternum nexus. In mathematics, 36 degrees is equivalent to pi divided by 5 radians.
Radians are just a different way to measure angles based on the radius of a circle, for anyone wondering.
Right. Dukas provides a proof showing that to achieve a continuous pi over 5 radian rotation, while perfectly maintaining the phi-based pentagonal cross-section we talked about earlier, you mathematically require both pi and phi to be acting simultaneously on the structure.
At the exact same time.
Yes. The author calls this the dimensional lock.
I want to try and visualize this dimensional lock with an analogy, because the jump from literal geometry to a bridge between spirit and matter is huge.
It's the biggest leap in the paper.
Think of the power grid in your house. The power flowing through the lines outside is alternating current. or AC power. It moves in a continuous oscillating sine wave. That is our pi wave continuous rotational energy.
Okay.
But your laptop computer cannot run on an AC wave.
Yeah.
It requires direct current, or DC power, which is flat, discrete, and stepped. That is our phi structure, the material biological machine.
If you plug your laptop directly into the AC wall outlet, you will fry the machine.
Exactly. You need the power adapter block on your charging cable. The adapter receives the AC pi waves, steps it down, and locks it into the discrete DC phi current that the machine can actually use. In Ducas's theory, the DNA molecule is the literal geometric power adapter plugged into the fabric of the universe. It converts the continuous pi energy into the discrete phi structure so that the machine of your biological body can run.
That is a highly functional way to visualize the author's mathematical intent. The paper technically describes this as a transition from a four-dimensional manifold, called D4, which represents chemistry and rotational symmetry, into a five-dimensional manifold, D5, which represents biology and discrete spatial shells.
So we are a literal dimensional step.
Dukas is arguing that life is literally the materialization of this dimensional transition. The eternum nexus identity, that specific pi-phi lock in the DNA, is the physical bridge connecting the immaterial wave to the material structure.
Okay, so if this specific pi-phi interaction is the universal source code for creation, the literal geometric blueprint that brings energy into physical matter, has humanity ever noticed this before?
You would think so.
If it's a universal truth, surely it would show up somewhere else.
Yeah.
The author makes a claim in Section 5 that is going to sound wild at first glance. Dukas argues that humanity knew this exact mathematics 15,000 years ago during what the paper calls the antediluvian or pre-flood period. And the proof offered is the construction of the pyramids of Giza.
It is arguably the most controversial historical claim in the paper. The text asserts that the exact same phi and pi operator ratios found in the microscopic geometry of human DNA were deliberately engineered into the macro-scale construction of the Great Pyramid.
I have to pause you there, because the skepticism alarm bells are ringing loudly. Standard archaeology and Egyptology date the Great Pyramid of Khufu to roughly 2500 BC, about 4,500 years ago. This paper is throwing a date of 15,000 years ago out there, which places it at the end of the last ice age. Is Dukas venturing into ancient aliens territory here?
To remain impartial to the text, we have to look exactly at what Dukas is claiming, and no, the paper does not invoke extraterrestrials. The author posits a purely human antediluvian civilization that possessed a highly advanced mathematical understanding of physics, what the text calls the operator codex.
So just incredibly advanced humans.
Dukas argues this civilization was essentially wiped out by cataclysmic entropic changes, perhaps tying back to the environmental collapses mentioned earlier, but left the pyramids as a mathematical transmission of this codex.
Okay, so let's look at the math the author uses to justify this claim, because the numbers are admittedly fascinating. The text points to the specific dimensions of the Great Pyramid. If you take the length of the pyramid's base and divide it by its height, the ratio is 1.309.
Which is significant.
Very. According to the paper, this is exactly equal to 5 squared divided by 2.
Yeah.
Furthermore, the text points out that this 1.309 ratio perfectly matches the geometric scaling factor of the phi shells in the DNA model we just discussed.
The correlations continue with pi as well. If you calculate the total perimeter of the Great Pyramid's base and divide it by the pyramid's height, the result is exactly 2 times pi. The architectural structure squares the circle.
Oh.
Dukas asserts that this level of dual mathematical precision is absolutely not a coincidence. The builders were not just playing around with stones and accidentally discovering the golden ratio.
The paper calls this the universal constructor concept. It outlines a progression. D2 is the geometric math expressed in stone, which is the pyramids. D-phi is the exact same math expressed in biology, which is DNA. And D infinity is the math expressed as consciousness or spirit.
It's a scaling law.
The core argument is that it is one single mathematical operator dictating form across all scales and all epochs.
Exactly. What Dukas is attempting to prove is that the same mathematical operators that construct the microscopic scaffolding of your cellular DNA were used to construct the monolithic slope of the Great Pyramid. It is one universal source code.
So they knew.
The author's implication is that the ancient builders possessed the foundational mathematical blueprint of the universe and intentionally encoded it in the most durable medium possible to survive cataclysmic entropy.
So Dukas is essentially arguing that when you look at a photograph of the Great Pyramid of Giza, you aren't just looking at a tomb, you are looking at a macro-scale limestone model of your own micro-scale DNA.
It is a heavy concept to digest.
That is massive. But let's bring it back to the biology, because this raises a massive logical question. If this master equation, this golden ratio lattice governed by pi and phi, is so rigidly mathematically locked, how does life ever change?
Right, where does variation come from?
Exactly. How is there variation? Why am I fundamentally different from you, and why aren't we all just static, identical clones? If the blueprint is mathematically flawless, how does Dukas account for the vast variety of species on Earth?
That is the exact problem Dukas addresses in what the paper calls the Nexus 17 proposal. This section introduces the adaptive biogenesis constraint equation. The author frames this specific formula as the ultimate mathematical refutation of Darwin's theory of unguided mutation.
The equation is written as delta n sub k. According to the text, this formula defines exactly what is physically permitted to change or mutate within a biological system. Now, we don't need to memorize the algebra, but we need to understand the variables involved because they represent the boundaries of life. Walk me through the components of this constraint equation.
The equation relies on three primary variables. The first is L sub 2k, which the paper calls the Lucas integer.
Lucas integers.
Yes. In mathematics, Lucas numbers are closely related to the Fibonacci sequence and the golden ratio. In this biological model, the Lucas integer represents the fixed geometric trend. It's the unchangeable, rigid ladder of the 5 shells that we discussed earlier. It is the hard scaffolding.
Okay, so L is the immovable structure. What is the second variable?
The second is R sub k, termed the primordial receptacle. This represents the entropy deficit.
Entropy deficit, so in simpler terms.
In simpler terms, it is the allowed margin of structural flexibility. It defines how much give the rigid system has before it breaks. It is the parameter space within which energy can be shifted around without destroying the core geometry.
Okay, so it's the wiggle room and the third variable.
The third is delta sub k. This is the intruder or the collapse shift. In standard biological terms, this represents the mutation itself. It's the environmental pressure or the internal error trying to alter the biological form.
So how do these three variables interact to refute Darwin?
The math rigorously dictates that the mutation variable delta k is strictly bounded by the receptacle variable rk. The equation puts a hard mathematical box around what a mutation can actually accomplish.
So mutations aren't limitless.
Not at all. According to Dukas' proof, mutations can only perform two functions. They can reweight existing structural shells, which the paper defines as adaptation, or they can cause the complexity of the shells to collapse entirely, which is the de-evolution we saw with the dinosaurs.
Let me bring in an analogy based on the text to really visualize the difference between adaptation and novel mutation. Think of biological life as having a fixed, pre-programmed set of design slots, almost exactly like the character creator menu in a highly detailed video game. The game gives you a set of sliders. You can adjust a slider to make the character's nose wider, or you can adjust a slider to make the jawline higher.
And moving those sliders represents the R sub k, the allowed flexibility within the receptacle.
Exactly. When Darwin observed the finches on the Galapagos Islands, he saw that some finches had short, thick beaks for cracking seeds, and others had long, thin beaks for reaching insects. Standard evolution says those different beaks are the result of random mutations creating new traits over time.
But Dukas disagrees.
Dukas's math says, no, those finches are just moving the pre-existing beak-length slider back and forth within the mathematically allowed receptacle. That is adaptation. You are just reweighting the parameters that were already coded into the game.
Right.
But, and here is the crucial limitation, the math absolutely forbids you from using those exact same sliders to invent a third arm or to generate a brand new functional respiratory organ from scratch. You cannot invent a new slider that the programmers didn't build into the code.
That is the core constraint. The equation mathematically proves that mutations cannot generate entirely new functional shells outside the pre-declared lattice. Generating a novel, viable shell like a new organ system would require the mutation variable delta k to operate outside the physical limits of their receptacle, rk.
And what happens if it does?
Doing so violates the core mathematical framework of the theory and results in structural collapse, not upward evolution.
This fundamentally redefines the entire concept of survival of the fittest. Under Ducas's theory, it is no longer a story about a species randomly inventing brilliant new genetic traits to overcome environmental challenges.
No, it's a completely different mechanism.
Instead, it's merely a test of which pre-existing parameter adjustments, which specific slider settings can manage to survive the rising environmental entropy. The environment doesn't select for upward complexity, it merely filters out the operator configurations that can no longer sustain their energetic demands.
The randomness of biology is entirely boxed in by the math. You can tweak what is already there, or you can break what is already there, but you cannot randomly invent new structural possibilities.
But if we follow this thread to its logical conclusion, it leads to a very uncomfortable question regarding the human experience. If biology is just a rigid, mathematically deterministic machine endlessly adjusting its sliders within strict limits until it inevitably collapses under entropic pressure, where does human free will come into the picture?
It sounds pretty bleak.
It does. Where does our consciousness, our spark of awareness, fit into a completely determined equation? Does Ducas's paper just reduce the entirety of human thought and emotion to a math problem?
Surprisingly, the paper takes the exact opposite approach. While it argues that the physical body is deterministic, it provides a literal, distinct equation for the human soul.
An equation for the soul. Wow.
Dukas argues that consciousness and free will exist in the interaction between the spiritual wave construct and the deterministic physical lattice. To explain this interface, the paper introduces what it calls the new Euler's equation.
Okay, we need to unpack this carefully. Euler's identity is one of the most famous and revered equations in standard mathematics. Before we look at Ducas's version, remind us what the classic Euler's identity is.
The classic Euler's identity is written as e to the power of I times pi plus 1 equals 0. Physicists and mathematicians often call it the most beautiful equation in mathematics because it elegantly links 5 fundamental constants of nature, ei, pi, 1, and 0, into a single, unified statement of material symmetry and unity.
It's essentially the mathematical baseline for how waves and circles operate in the physical universe.
Yeah.
But Ducas alters it. The paper introduces the Eternum Euler.
Yes. The Eternum Euler modifies the classic formula. It is written as e to the power of I times pi, multiplied by the quantity of pi squared minus 1, all divided by 5 plus phi sub 7 equals 0.
That is significantly more complex.
Okay.
But the text focuses heavily on one specific piece of that new equation, the pi squared minus 1 term. If you calculate pi squared minus 1, you get roughly 8.8696. The author designates this specific number as the spiritual remainder.
Dukas defines this spiritual remainder as the domain of eternal memory and will. Notice that it sits outside the pure pi rotation and the phi physical structure. It is a mathematical remainder that is not absorbed by the deterministic physical lattice.
So it's leftover energy.
Exactly. Therefore, the paper argues it represents the non-deterministic aspect of our reality consciousness.
But how does a mathematical remainder of 8.8696 translate into my daily thoughts and choices? How does the immaterial spirit actually command the physical deterministic body?
Dukas points straight back to the biological structures in the brain, treating them as literal physical antennas.
Antennas, like radio antennas.
Literally, yes. The paper details the specific microgeometry of human brain cells. It looks at dendritic trees, which are the highly complex branching structures that neurons use to receive signals from other neurons. Dukas notes that these dendrites branch at an average angle of 137.5 degrees.
Is that a significant angle?
Very. In biology, this specific golden ratio angle is called phyllotaxis. It's the same mathematically optimized pattern used by plants to arrange their leaves for maximum sunlight absorption.
Oh, wow. And the text also examines the internal scaffolding of the cells, the microtubules. These are the tiny tubes that give a cell its shape. Dukas points out that mammalian microtubules are constructed of exactly 13 protofilaments, a number that geometrically matches a phi to the 4th power lattice.
The argument being constructed here is one of structural resonance. The brain's architecture and the DNA inside its cells are not merely chemical data storage systems, they are dynamic geometric wave receivers.
So they're literally built to catch a wave.
Yes. The math of the Eternum Euler equation simultaneously generates both the 10.5 base pair geometry of the DNA molecule and what Dukas calls the phi sub 7 soul wave that propagates cleanly through that specific geometry.
Let me summarize this with an analogy to make sure I am grasping the author's full claim. The paper is stating that the physical body The meat, the bones, the chemistry is completely deterministic. It strictly follows the phi math. But our awareness, our internal voice, exists entirely within that pi squared minus 1 remainder.
Right.
Our physical brains and our cellular DNA are literal, mathematically tuned antennas. They are spiritual interfaces built to catch the broadcast signal of the soul and then convert that immaterial signal into physical action using the mutation operator we discussed earlier, the delta K variable, which Dukas actively refers to as the free will operator in this context.
You have the mechanics exactly right. The physical, material world executes the discrete steps, but the immaterial soul commands the rotational wave. Every thought you have, every moment of conscious awareness is a dimensional transduction happening in real time.
It's happening right now as we speak.
Exactly. The physical mechanism is governed entirely by determinism, but the awareness driving it transcends that physical system.
That is a profound philosophical shift. It completely upends the modern neurobiological view that consciousness is simply an emergent byproduct of chemical reactions in the brain. According to this framework, you are not your body. You're a transcendent, mathematically defined entity operating a perfectly engineered biological mech suit, broadcasting your will from a higher dimension.
It separates the source of the signal from the biological receiver, and doing so raises an immediate, highly consequential clinical question.
Which is?
If consciousness is a pure signal being caught by a biological antenna, what happens when a person experiences severe mental illness? If the brain isn't generating the consciousness, how does this mathematical framework attempt to treat psychiatric pathology?
Right. In the final sections of the paper, Dukas actually applies these physics directly to clinical psychology, attempting to create a mathematical cure for the mind. The text makes a foundational claim. Memory is inherently spiritual, not purely biological.
Which, again, is a massive departure from standard science.
Huge. The paper defines memory mathematically as m equals negative 0.111. Because memory originates in the spiritual domain, that pi squared minus 1 remainder, treating a diseased mind, requires addressing all levels of the system simultaneously. To do this, the author introduces a treatment framework called the three-gate cascade.
The three-gate cascade maps the process of thought directly onto the mathematical operators we've been discussing. Gate 1 is the spirit, which is the origin of the signal. It is mathematically governed by the equation theta plus m equals pi squared minus 1.
Okay, that's gate 1.
Gate 2 is the DNA and the soul, which acts as the transducer or the antenna catching the signal. And gate 3 is the biological mind, which is the physical brain tissue where the signal is finally executed, governed by the formula phi plus the absolute value of psi equals 1.
So how does mental illness like severe trauma or memory disease actually occur in this mathematical model?
The text explains that pathology occurs when there is a disruption at the source. Dukas calls this a spiritual memory overweight. In the math, this is represented as delta m is greater than 0.
Meaning the memory is too heavy.
Basically, yes. This means a trauma or an excessive memory burden distorts the pi squared minus 1 signal. That distorted spiritual signal then cascades downward through the DNA antenna, which is gate 2, and finally disrupts the biological balance in the physical brain, gate 3.
And how does that show up biologically?
Biologically, this manifests as amygdala or hippocampus dominance, which is what we physically experience as panic attacks, chronic anxiety, or trauma responses.
This is a radical departure from standard psychiatry. We typically treat mental health as a purely biological issue, a chemical imbalance in the brain. We prescribe a pill to adjust the dopamine or serotonin levels, attempting to fix the biology.
But Dukas argues that won't work long term.
Right. Dukas is arguing that standard psychiatry is like trying to fix a horribly distorted radio broadcast by endlessly changing the batteries in your radio receiver, completely ignoring the fact that there is a massive thunderstorm interfering with the broadcast tower miles away. You cannot permanently fix the biological receiver if the spiritual signal it is receiving remains distorted. You have to address all three gates.
Exactly. The treatment protocol outlined in the paper attempts to work backward to re-equilibrate all three gates. Step 1 is priming the biological mind using therapeutic techniques to activate the prefrontal cortex and physically calm the biological flatus.
Calming the hardware down.
Right. Step 2 is isolating the corrupted memory by decoupling the biological response from the amygdala. But step 3 is the most crucial in this framework. It requires using resonance-specifically deep meditation, targeting the pi squared minus 1 frequency to reach back up into the spiritual gate and rebalance the eternal memory and will equilibrium at the source.
Dukas is attempting to integrate physics, psychology, and spirituality into a single, cohesive, mathematically proven architecture. The paper argues that the algebraic spirit generator and the geometric soul generator must work in perfect harmony to form the master equation of life, which it labels psi-TDUFT. The author claims this framework permanently removes the artificial separation between medical diagnosis and profound existential meaning.
It is an exhaustively comprehensive theory. As an impartial observer of the text, the scope of what Dukas is attempting to unify is staggering.
It really is an incredible, paradigm-shattering journey this text takes the reader on. We started with Dukas's mathematical assault on Darwinian evolution, the assertion that the probability of random chance building the immense complexity of a single cell is practically zero.
We move through the specific geometry of DNA, examining the author's claim that the golden ratio and pi perfectly construct the physical scaffolding of life, supported by statistical chi-square proofs. We looked at the controversial assertion that this exact same universal mathematics was encoded into the antediluvian pyramids 15,000 years ago.
We explored the deeply counterintuitive idea that life does not evolve upward, but rather adapts within strict mathematical limits, often de-evolving or shedding complexity to survive entropic pressure. And finally, we unpacked the exact equations Dukas uses to map the immaterial soul to the biological brain, arguing that memory and free will operate through the DNA, acting as a fractal antenna.
To summarize the profound philosophical weight of all these equations, there is a powerful quote from the text that stands out. "We do not find God at the end of a search. We become aware of where we have always been." Dukas asserts that space-time itself exists entirely within mathematics, and mathematics exists inherently in the mind of the creator. In this framework, humanity is not standing on the outside looking into the universe. Everything we are and everything we experience is already inside that designed operator system.
As we wrap up this deep dive, I want to leave you with a final provocative thought to mull over based on the author's mechanics. If your cellular DNA is a precisely engineered golden ratio transformer built specifically to bridge your spiritual wave into the physical world, what actually happens to your pi-squared spiritual remainder? Your soul's unique signal when the physical phalatus of your body finally breaks down at the end of your life. If the mathematical equation driving the signal is eternal, as Dukas claims, maybe the broadcast never actually stops. Maybe the signal just waits for a new biological receiver.
According to the strict mathematical definitions in TDUFT, the signal is a universal constant. It reframes the fundamental nature of existence and death entirely.
It really does. Thank you so much for joining us on this deep dive into the mathematical architecture of life. Keep questioning the paradigms, and we will see you next time.